Good morning, everyone. The topic that we are going to discuss today is the klystron. The klystron is a form of an amplifier that is used to amplify the signals in the microwave ranges. We're going to see about the two cavity klystron amplifier. And as the name suggests, the two cavity klystron amplifier has two cavities, namely the buncher cavity and the catcher cavity. Before analyzing the two-cavity klystron amplifier, let us first see the schematic of the two-cavity klystron amplifier and its basic working principle. Observing this diagram, we can see that it contains two cavities, which is the buncher cavity and the catcher cavity, and that is why the name two-cavity klystron amplifier. There is a cathode that is present at the leftmost, which is responsible for emitting an electron beam. So we know that the cathode is at a negative potential. This buncher cavity is positive potential with respect to this cathode. Because of the opposite polarities, the electrons are attracted towards the buncher cavity and they start moving towards this particular space. The electrons first reach the buncher cavity space. And if you see in the buncher cavity, we provide an RF input signal of a lesser amplitude that has to be amplified. This RF input signal induces an electromagnetic field in this buncher cavity. So, due to the presence of this electromagnetic fields, the electrons that passes through this space, through this gap, experiences some force. And because of this, certain electrons are accelerated, certain electrons are decelerated, and certain electrons move at the same speed. So the electrons start moving through the drift space, and we can see that certain electrons move slower. Certain electrons move very fast, so they join the slow electrons. Certain electrons move at the same speed. So what happens? The slow electrons and fast electrons start forming bunches. And this is what we call as the bunching process. So due to the field that is present in the buncher cavity, the electrons are accelerated, decelerated, and the electrons start forming bunches in the space called as the drift space. So these bunch electrons have a more energy when compared to the electrons previously. This large amount of energy is enough to induce another electromagnetic field when the electron reaches the catcher cavity, and this EMF is going to be much more stronger when compared to the field in the buncher cavity. And this strong EMF is what is responsible for producing the amplification of the signal. So the electrons, after transferring its energy, which is responsible for the amplification process, is finally collected back at this collector, which is grounded. So this is the working principle of a two-cavity klystron amplifier. So it works on two main principles, which are namely the velocity modulation process, which is nothing but the field that causes the velocity of the electron either to increase or decreases the velocity, or the electrons move with the same velocity. And this is what is responsible for the bunching process. So it works on the principle of velocity modulation and current modulation that causes the amplification of the signals at the RF range. Before proceeding with the analysis of the two-cavity klystron amplifier, we need to understand two basic assumptions that are made for analyzing the two-cavity klystron. The first assumption is the electron beam is assumed to have a uniform density because the electrons are emitted by using the cathode and the same electrons are collected by the collector. What gets changed is the velocity of the electron and the energy that is possessed by them. So because of that reason, since the cathode emits an electron and the same electron is collected at the collector, we assume that the electron beam is traveling with a uniform, it possesses a uniform density. Second important assumption that we make, the magnitude of the input that we are giving to be amplified. So we give an RF input here that has to be amplified. We consider that RF input to be very small when compared to the DC voltage that is given here. So we assume the RF input which has to be amplified is very less than the input that is given to the klystron. So we assume almost V1 to be 0. So such a small signal is going to be amplified. So we assume this to be nearly equal to 0. So when V1 is equal to 0 almost, 0 by anything becomes 0 for us. And therefore we usually write V1 by V0 is almost equal to 0. This is the second important assumption that we make in the two-cavity klystron amplifier. So this is the schematic and the working principle of the two-cavity klystron amplifier. In the next video, we will start with the analysis of the two-cavity klystron amplifier. Thank you.